Good evening, guys. How are we doing today? I want to believe you're doing well. And I want to believe you guys enjoyed your Sunday. Don't mind me. It's Sunday. I'm computing this video. I just like wishing all you, my Christian, and all of you a good day. God bless you. And please keep praying for all of us. Now, we want to go to piecewise function. Oftentimes, piecewise function has been function that a lot of students have issues understanding. What's the meaning of piecewise function? What does it mean? Now, how do I understand if a piecewise function is continuous? How do I know if a piecewise function is not continuous? Oh my God, piecewise function is giving me issue. Just listen, stay through the course of this video. I assure you, 100%, you handle piecewise function and you'll see a lot of things about it. In the meantime, let's get to it. And please, if you haven't subscribed to our channel yet, please, you're doing yourself a great let me tell you that. I don't mean a bad way. I don't mean a bad way. But at least once you subscribe, you turn on the notification button. Once you drop a video like this, educative video, you'll be the one. I mean, the first person to see it. As it will always notify you once the video is dropped. So please, before you go, just write down, right here. Go and subscribe. Yes, go and subscribe. Subscribe, turn on the notification bell for you to get more educative video. We are here for you. Everything matters. This is the home of mathematics demystification. Now, let's get to it. We say a piecewise function is a function that is defined by different formulas. That is, there will be formulas or expression on different parts or pieces of its domain. Don't forget two things. It is defined, it's just like every of a function, like a general polynomial function, p of x equals to 2x plus 4. Now, we tell you that the domain of p of 4 is what? From real number to real numbers. From negative real number to positive real number. And then the domain of that kind of function, don't mind me, the domain of that kind of function, you think of a domain, I'm not saying for piecewise, and for general polynomial function, you can have a function like this, which is 2 plus 4x. And then we tell you that the domain where x, that is the domain, s is in real number. This function is defined on all real numbers. This is a general polynomial function. You have other functions too. But what if you now have a function such that it is not just one particular expression, it's not just one particular formula that define the whole thing. We break the whole function into pieces, and each piece has its own domain, has its own part to which it is defined. And if I mistakenly leave the part where a function is defined, then definitely I'm doing the wrong thing in a piecewise function. So we say, in the other word, the function change its rules. That is, every piecewise function you have, it changes its rules depending on the value of x. That is, depending on the input. That's a piecewise function. If we give you a piecewise function now, there will be a definition. Every part has its own expression. Now take a look at this. We say mathematical form f of s equals, this is the f of s. Now this f of s now have its sub functions. This is the main function, has its sub function, its composite function, constituent that eventually make up f of x. We now say it is f1 of x if x is in the domain of 1, and it will be f2 of x if s is in the domain of 2. It will be f3 of x if s is in the domain of 3, down to fn of x if s is in the domain of n. Now, what are you trying to say? We say each piece fi of x. That is, this one I here is 1, f1 of x, I here is 2, f2 of x, I here is 3, f3 of x, down to I here is n, fn of x, defines how f of s behave on a particular interval. That is it. We give you an interval to which the definition hold. Are you getting what I'm saying now? We give you an interval to which the definition holds. Now take a look at this. This is f of x equals, we give you the linear part here. This is f1 of x and this is f2 of x. Now we say f1 of x hold when x is less than 0. That is, if they give you, okay, if somebody now say what is f of minus 1, you're using this part. Because minus 1 is less than 0. What is f of minus 7? You are using this part. Because minus 2 is less than 0. So if somebody say what is f of minus 7 now, f of minus 7 is going to be what? Anyway, because we are using this part, because it's the part, this is the definition for negative values, for values less than 0. So you're definitely going to put what? Minus 7 to this. minus 7 plus 2. And definitely f of minus 7 is what? Minus 5. But then the beauty of the definition, that same function, f of x, has this part. We say it is x squared when s is greater than or equal to 0. So if they give me any 0 or numbers greater than 0, 0 or numbers greater than 0. So I'm definitely going to put it what? In this second part. If somebody asks me what is f of 0.1, of course, 0.1 is greater than 0. That will be 0.1 square. For the same function. What if somebody say what is f of 3? That will be 3 square, 9. For this same function f of x. So it should be changing depending on where that particular point you're interested in the category is for. If it falls to this category, you're going to use this part of the definition. If it falls to this category, you are going to use this what? This part of the definition. That's what a piecewise function is. Are we get what I'm saying at all? Now, this means the graph is made of two different curves joined together at x. Well, actually, this one is not joined. It is joined at x if this end point here, or point w is certain, they give us the same value. If by insertion they don't give us the same value, I'm sorry, it shouldn't work. So this one here, there will be a joint discontinuity here. All together here? Thank you.